And welcome to Empowered Learning. This particular video is a continuation of the chain rule video. If you're not familiar with chain rule, or if you're looking for basic skills building type of examples for the chain rule, then I suggest that you watch my previous chain rule video. If you're looking for applications on how to use chain rule, then you're in the right place. I have an example here, so let's go ahead and get started. So what we want to do here is find the equation of a tangent line to this particular curve at this particular point. And so we know whenever we find an equation of a line, we know that we need a slope and we need a point. Okay. And so since we already have the point, we're just going to look for the slope. And we know that that connection in between the function and its derivative is that if we take that function, find its derivative, and then evaluate it at a particular x value, that will give us the slope of the tangent line at that particular point. So that's what we want to do here. So we want to start off by finding out what is going to be the slope of the tangent line by finding the derivative of this particular function evaluated at our x value, x equals 3. Okay, so let's go ahead and do that. So first thing that we want to do is take our function y and we're going to rewrite it as an exponent here, something with a fractional exponent. So from here, we'll take the derivative, and I'm going to use the prime notation here. So if we do that, this will be 1/2 times blah raised to the 1/2 minus 1. Okay. And so since we see that this is what we call a composition function, where we have a function stuffed inside of another function, then we're taking the derivative of the outside function with respect to the inside function looked at as a variable first. So that's what this part is. Since we're looking at 4x minus 3 as just a variable in this case, we have to put in 4x minus 3 here. Okay. Now the second part of the chain rule says that once we take the derivative of the outside function with respect to the variable here, now we have to take the derivative of the inside function with respect to the original variable, which is x here. And so we'll just do it like that, 4x minus 3, all that prime for short. So from this point, we'll go ahead and clean this up. And we see that this is 1/2 times 4x minus 3 raised to the negative 1/2. And if we do the derivative of 4x minus 3, we know that that's just going to be 4. The derivative of 4x is just 4. The derivative of any constant is 0. So all this just ends up being 4. And so from here, 4 times 1/2 is 2. And then if we rewrite this in terms of having it in root, then the derivative of our function will look like this. Okay, so from this point, what we need to do next is evaluate this particular function when x is equal to 3. So if we go ahead and plug that in, you'll see here that we have 4 times 3 is 12. 12 minus 3 is 9, and square root of 9 is just 3. So our slope here would be a positive 2/3. So now that we have what our slope is, and we already have our point, life is easy, because all we need to do is use, this is x1, that is y1, and then find the equation of the line. So I'm going to employ using the point slope formula for an equation of a line. Take this slope, plug it in, take these two x and y coordinates, plug it in. So we have y minus 3, 2/3 times x minus 3. And then from that point, we just simplify. So we'll solve for y, I should say. So we'll start off by distributing. And then we know that all this is just 2. And then from here, we'll add 3 to both sides. And so this would be the equation of the tangent line for this particular function. Now, one last thing I want to do is to show you graphically, when we are asking this, what this actually means from a visual or graphical standpoint. So here, if we actually took this particular function we could figure out what it looks like in terms of transformations by doing the following. So we could factor out a 4 out of the radicand, and we'll have this. And so from here, we could rewrite this problem this way. And of course, square root of 4 is 2. So this, at the end of the day, would just look like 2 times square root of x minus 3/4. If we were to draw that particular function, it would look like this. Okay, because of course, square root function kind of looks like that. And so from here, we know that we're trying to figure out what is going to be the equation of the tangent line when x is equal to 3. So if x is equal to 3 is here, then it has this point. And of course, we know that when x is 3, according to what the problem said, y is 3. And so if we're trying to find the equation of the tangent line, the actual line that we are finding the slope of is this one. Okay? So when we find this, this is exactly what that line is. And of course, that would be a y-intercept at 1. So from a visual perspective, this is what we're actually doing, trying to find the equation of the red line here.